All right, everybody. Glad you decided to join me this evening as I get this set up. This is the study session for test number 4. Please let me know that you can hear me. Excellent. It's here. All right. Good evening. Good evening. All right. Let's go ahead and get this started. I'm bringing up the study guide. All right. Are there any questions that you have before I get started? Again, the usual way that we do this is about an hour, and I go through these questions in order, unless unless someone has any questions they want me to start with first. All right. What what numbers are they? And this will be, oh, I'm sorry. Question 7. No, the final's not. Check the syllabus for the final for the breakdown for the final exam. Sorry, just one moment here. This. So, okay, sorry. The YouTube thing that I use. Oh, here we go. The YouTube thing that I use records it backwards, believe it or not. So you have to bring it up so that I can actually see it. Right. Okay. So yeah, here. Question 7. Yeah, first question. 4 cosine of 2x is equal to 5 minus 4 sine x. Is this your question? The final is cumulative. The 2 is the power. All right. What about that? Does that look like what your problem looks like? All right. Excellent. Okay. So to solve this problem, that was really hard, but it's not. All right. So the first thing that you want to do is to use one of the Pythagorean identities, change this to something sine, because you want all sine or all cosine, because this is looking kind of quadratic. So this becomes 4 times 1 minus sine squared of x is equal to 5 minus 4 sine x. Okay, from here, you distribute this 4 to both of these terms, and get 4 minus 4 sine squared of x is equal to 5 minus 4 sine x. The way that factoring works, most of the time, you want one side equal to 0. So we're going to move everything to the right side of the equal sign. And we're doing that because we prefer to have the number in front of our squared term. So I'm going to add 4 sine squared x to both sides. And I'm also going to, at the same time, subtract the 4. So that there is nothing on that side. 5 minus 4 is 1. Minus 4 sine x plus 4 sine squared x. And if I move it around a little bit, 0 is equal to 4 sine squared x minus 4 sine x plus 1. All right. So at this point, this looks like a quadratic equation. There are a few different ways that we know how to solve. Let's see. 4, 1. The I don't know if this one plans on us using the quadratic formula. That is I call it the sure thing. The quadratic formula is it always works. That being said, it's also, I'm not going to call it the most complicated, but it has the most little steps to it. So I'm looking at it to see if there is, number 60. Madison, I'll do that one next. So I'm looking at this to see, is there two? I think so, yes. I have to work hard with this one. Okay, so 0 is equal to, what I did was, and to try to explain it, and I mean, please bear with me if you already know how to factor. Try not to backtrack too much, but basically, uh, it's like, because this is a minus and this is a plus, I know that the two factors are going to have a minus and a minus. Okay, so and then I look at the factors of the 4 and the factors of the 1, which is just 1, and see which other factors add to equal, which combination of factors add to equal -4. That's a whole lot harder to do that, to explain it, than to do it. We can talk about factoring offline if you'd like to do that. But basically, I have 2 sine of x minus 1 and 2 sine of x minus 1. And obviously, my subtraction signs didn't go in the right place. But minus 4 plus 1. This is what it is. And this is equal to 0. So this times this is equal to 0. Now, in our case, these two things are the same thing. But if they weren't the same thing, that means that one or both of these factors, the part in the parentheses, would have to equal 0 in order for this to equal 0. That is called the zero product property. It is one of the big things that makes factoring work. So from here, this means that 2 sine of x is equal to, or minus 1 is equal to 0. Have 1, 2 sine of x is equal to 1 divided by 2. Sine of x is equal to 1/2. All right, let's see. This is from Deborah. Deborah, were there any other stipulations to the problem as far as like the interval of the solution? Because without that, there can be theoretically an infinite number of solutions here. X is equal to arc sine of 1/2. All right, if we do on the regular interval 0 to 2 pi, right? 0 to 2 pi, that's basically saying where sine of x is equal to 1/2, where from 0 to 2 pi. All right, and we know that in this case, x is equal to pi over 6 and 5 pi over 6. So these are two solutions to where sine of x is equal to 1/2. That is the solution to our equation. All right. Next problem is one like number 60. Oh Lord, graphs. Okay, let's do it. Oh, you're welcome. Oh, that's not right. Let's see. What am I doing? Sorry, I like for this thing to be lined up right. So more this way. Okay, so basically we have two rational functions. We're trying to see what the graph looks like. So the first one is f of x is equal to 5 over x squared minus x minus 8, and g of x is equal to 2x over x squared minus squared minus 9. Okay, as is obvious, I can't show you all the graphs and go through them like that, but I will show you how to do some of the properties. The first step is we factor these. Not cancel if you don't have to, but to factor them. And this becomes 5 over x plus 2, x minus 4. And this one becomes 2x over x plus 3, x minus 3. Now, when you do the choices, you're looking at a few things. All right. First, let's take f of x to look at first. So we'll say A. This is for f of x. We know that f of x is never equal to 0, because for a fraction to equal 0, that means that the numerator is equal to 0. The numerator is 5. It's never equal to 0. So when you look at your graph, you see if anything is going through the origin. It's never going through the origin. So y is never equal to 0. It does not touch the x-axis. The second thing you look at is where are the asymptotes? Asymptotes are the little dashed lines that are horizontal, not horizontal, that are vertical. These are values that x cannot equal, because it would make this rational function something over 0. In this case, x is not equal to negative 2, and x is not equal to positive 4, because here x plus 2, negative 2, in here makes this factor 0. 4 makes this factor 0. So it can't be either one of those. The next thing you want to look at is kind of the end behavior of the function. We look at the degree of the highest exponent on a variable in the numerator and the highest exponent on the for a variable on the denominator. If we look back here, we see that this is x squared on the bottom. There's no variable on the top. So that means that this graph approaches 0, and it's positive. So this graph approaches 0. As x gets infinitely large, this gets close to 0, but it never actually touches. Similarly, when x gets infinitely small, this approaches negative. I don't like to use this type of language because it starts touching calculus a little bit, and I like to leave that subject alone. Like, I like to keep it separate, but know that this approaches 0, and it can't equal these two numbers. Okay, so from what I'm looking at here, um, you can look at the graphs and start to eliminate graphs to figure out what you're looking at. Okay, for this one, for this problem, we'll call this B. We know that G of 0 is equal to 0. So I put in 0 here. 0 over negative 9 is 0. So this crosses through the origin. I put 0 in for x, and I get 0 out for y. So 0, 0 is a point. I also know that x in this case cannot equal negative 3 or positive 3. All right. I also know that this graph also approaches 0 as this x gets big. This has a different asymptote called the slant asymptote. We're not really going to talk about that in this course stuff. We know that this gets infinitely large, This doesn't get as large as fast. So this approaches zero as well. So I don't know if that helped answer your question for for question like number 6. But you're looking at kind of the characteristics of your function to see, which graphs look like that. Excellent. All right. If you have any specific questions about yours, let me know, and we can go through. We can go through that offline. But I hope that helps. Anybody else have any questions? Definitely let me know. I'll go ahead and just start working through them. I did scramble the questions a bit. Maybe. I hope I scrambled up the questions. I actually don't remember if I did or not. If you have any questions, feel free to interrupt. Okay, there we go. So this will be our third question. We have a similar to one that we just did. 2 sine of theta minus sine of 2 theta to 0. All right, our variables, and this is, of course, the solution is on the normal interval. Normal interval from 0 to 5. All right, so again, we like all of our trig functions to be the same. In this case, our variables are different, and our variables have to be the same too. So we're going to change this to sine of theta minus sine of 2 theta. That there is what's the word? There's an identity for that. It's called a double angle identity. Okay. So sine of 2 theta, we know is 2 sine of theta cosine of theta. All right. So both of these terms are, if you have numbers and variables that are separated by plus or minus, both of these terms have a sine of theta in them. So we're going to factor that out. We're going to do the distributive property in reverse. They also have a 2. So we'll take that 2. So this becomes 2 sine of theta. And left over is 1 minus cosine theta. And that's equal to 0. All right, so I have two things. This is in parentheses, but it doesn't have to be. There's kind of operation in it. So this one part times this one part is equal to 0. If two things multiplied equal to 0, one of the two things, one or both of the two things have to be 0. So that means that 2 sine of theta equals 0, or 1 minus cosine theta is equal to 0. Either one of those can be true. So if that's the case, that means that sine of theta is equal to 0 because 2 can. And where sine of theta equals 0, at theta is equal to 0. 1 minus cosine theta is equal to 0. If I subtract 1 from both sides, I get negative cosine theta is equal to negative 1. It means positive cosine theta is equal to positive 1. And cosine theta is equal to 1 at theta is equal to 0 and no, to 0. So sine of theta is 0 at 0 and pi. Sorry about that. Brain freak. Cosine is 1 only at 0. So my answer is theta is equal to 0. And my brain froze up on that yet. No, sine is 0 at two places. All right. Next up questions. Another equation. But we haven't seen this before yet, so root 3 cotangent of theta minus 1 is equal to 0. And of course, we're on 0 to 2 pi, which is basically our unit circle. Okay, so same type thing. You want the trig function by itself. So root 3 cotangent of theta is equal to 1 divided by root 3 cotangent of theta is equal to 1 over root 3. Now, if you know the value of cotangent of theta, then, well, we know that this 1 over root 3 is the same thing as root 3 over 3. If you don't know that, then get me. We can talk about that. Where is cotangent of theta equal to root 3 over 3? Some of us know that, but most of us don't know that. Most of us are not aware of that. So one of the really cool things you can do is you can flip cotangent. If you flip cotangent is x over y. So if you flip that, that becomes y over x, which is tangent. So I can flip this, and I can flip the fraction on the other side too. Okay, we're not going to flip this one because we did work with this. We're going to flip this one. And that becomes root 3 over 1. And you might not know where theta tan of cotangent of something equals something else, but you should know where the tangents are, or that should be a unit circle. You know that tangent of theta is equal to root 3 in 2 places, at pi over 3 and at 4 pi over 3. Quadrants 1 and 3. A lot of words with that, but I hope that I think that rather I over-explained it, under-explained. Okay. Next question is something a little different, but something I like this also. So we're going to simplify 4z cubed over z to the negative 4 to the negative 2. All right. So there are a few different ways that we can do this. Okay. A few different ways that we can do this. The first thing that we normally like to do is get rid of the negative outside. That becomes z to the negative 4th over 4z cubed squared. Okay. Next, we see that this is a negative 4 on the top and a 3 on the bottom. The easiest way to maybe understand it, if you don't already understand it, to understand how to deal with these exponents is if the bases are exactly the same, I do the top number exponent minus the bottom number exponent. That becomes z to the negative 7, because negative 4 minus 3 becomes negative 7 over 4. Okay. The squared is out here, so I'm going to square the top and the bottom, and I end up with z to the negative 14th over 4 squared, because I squared, and let me know if I need to write this step out again. I need to expand this step to show every little piece of it. 4 squared, which is z to the negative 14th over 16. And then because I have a negative exponent, I move it to the bottom. If it's on the top, I move to the bottom. If it's on the bottom, I move to the top. So that becomes 1 over 16z to the 14th. And that's my answer. All right. All right. Next problem. That's 5 for us. So this will be the 6th problem. It's similar to what we've been doing. It's a little bit different. So I'll go ahead and show that. All right. So I have cosine of 3x is equal to 0. And we want all solutions. We want all possible solutions. All right. So here's how we do it. So if we okay, I'm gonna try to move slow. So so that we don't get confused. So if we take the arc cosine on both sides, which really is an operation, there really is a range limitation on this. But we're going to take that away for our purpose. I'm just writing it like this so you know what the step is what we're doing. Okay. Where does cosine theta equal 0? That's what this means. Where does cosine equal 0? And we know that cosine is equal to 0 at pi over 2, and then at 3 pi over 2, so I'm right over here. So we know that this is at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. So basically it's pi over 2, and then I'm adding a half rotation. I'm adding pi to each one, which is 2 pi over 2. I'm adding pi to each one of these. So it's pi over 2 plus k times pi. And where k is an integer. That's what this means. K is in integer. That's what that means. That means all the positive and negative multiples, all positive and negative numbers can sub in for k. So that's all the integers. These are all positive and negative whole numbers and 0. All right. But I still have this 3. So I divide this by 3, that by 3, and that by. So I end up with x being equal to pi over 2 divided by 3 is pi over 6. And then I just say 1/3 k times pi. And k is still an integer. This doesn't change. So it's like I solve it and then I have to divide it by 3 to make sure that I cover everything. So this is our x. I hope that was clearer than mud. Like I said, with what we're doing, I feel like I'm giving a lot of words, but I'm hoping that it helps. This is kind of the same thing. This is kind of the same thing for an answer. Yeah, this is kind of the. I might. I'll try this. I'll try this one. Let me know if you get confused or not. I'm trying not to. I'm trying not to. All right, we have another one where we have 2 sine of 2 theta over 3 plus root 2 is equal to 0. We want all solutions. We want from 0 to 2 pi. Okay, so first we solve per usual. Minus root 2, minus root 2. 2 sine of 2 theta over 3 is equal to negative root 2 divided by 2 divided by 2. So I get sine of 2 theta over 3 negative root 2 over 2. All right. So first we'll find all solutions. Okay. First we need to know where we kind of take the 2 theta over 3, and we're going to take arc sine of negative root 2 over 2. Now again, we're not actually taking the regular arc sine, because the regular arc sine has a range of negative power 2 to power 2. We're not actually taking the actual arc sine. Again, I'm doing this so that you see what kind of the logic is behind what we're doing. So where does, y'all can see that, where does sine equal negative root 2 over 2? Well, that's at hold on, unit circle 3, 4 pi, 5 pi over 4, and 7 pi over 4. And we can keep going, right? So let's just start with those. Okay. So if 2 theta over 3 is equal to 5 pi over 4, or 2 theta over 3 is equal to 7 pi over 4, we'll solve both of these. To get rid of a fraction, you multiply by the reciprocal. Because 2 over 3 times 3 over 2 is equal to 1. So it gets rid of that, and then I multiply this by 3 over 2. Right? So I get theta is equal to 15 pi over 8. All right. And for the left-hand one, I multiply by 3 over 2 as well. Cancel. I get theta is equal to 21 pi over 8. All right. So these are the first two answers to the equation. Now this one, 15 pi over 8, this is less than 2 pi, because 2 pi would be 16 pi over 8. So this checks. This one is 21 pi over 8. This is larger than 2 pi. This answer does not check out because it's not in the range that we want. So this is going to be our answer. Any other answers that we do where we come up here and we do extra rotations, any extra rotations I make are going to be bigger than 7 pi over 4, which means it's going to be bigger than 21 pi over 8, which means you never to use it. It's going to be too big. Similarly, if we make negative rotations, well, then we have numbers that are less than 0. So this is our only. This problem was tricky. I am hoping that this explanation makes sense. If it didn't, please let me know. But it's one of the more complicated ones. But if you can possibly see it, I want you to be able to see it. Okay. Let's see. This problem is. Let's see. Let's see. This problem is. Let's see. 0 to pi. This is a calculator problem. I don't want to do it, but I kind of want to do it so that you see. Again, it's all these things that we were doing are similar, but it's stuff that it's a little different enough for me to want you to know what you got. this sine of theta is equal to negative 0.5363. All right. Calculator. I'm using TI-36X Pro, which is very similar to the allowed calculators that you can use. So what I'm going to do is I'm going to press, you see the negative one? See that? All right, this is arc sine. I'm going to take the arc sine of negative 0.6. That's going to give me that number. Okay. Now, wait a minute. Hold on. 0 to 2 pi. Let me go to my mode. I am in degrees. I want to be in radians because it says 0 to 2 pi. So if I go back up to the same problem, you see, I get another answer. This is my answer in radians. I want to make sure that my answer is in radians. It says give your answer in radians. You want to make sure about that. Anywho, okay. So this number, I'm going to put theta is equal to negative 0.5660. I'll just leave that like that right now. Okay. So there are two angles that satisfy this. Right. Well, first, if I take the arc sine of this, the arc sine, the operation I took was arc sine. Arc sine has a range of negative pi over 2, pi over 2. In other words, any answer you get for arc sine is going to give you something in this range. But it's going to give you this, which is a reference angle. Okay? This is going to give you, this is a reference angle. This is what this in radians, this is in quadrant, or normally in quadrant 1, what we would be looking at. Okay, but as is obvious, this is not in quadrant. This is in quadrant 4. This is on negative. They don't want negative, they want positive. Because they want our answers to be from 0 to 2 pi. So that's theta. This is our reference angle. So again, showing you on the unit circle. Theta, let's say, is right here. Okay. So if you look at this y value, there are two places that this y value exists. We want to find both of them, the rotation to be positive. So what I'm going to do is I'm going to take this number. I'm going to take this number and I'm going to add this, the positive of this number, to pi. I'm going to add it to pi, which is right here. Okay, so it's the first answer is pi plus 0.5660. And I can do where'd you go? Pi plus 0.5660. That's not a zero. And I get 3.7 round to the nearest hundredth. 3.71. That's my first answer. For my second answer, again, we have 2 pi minus this reference angle. 2 pi minus this reference. So I'm going to do 2 pi minus 0.560. All right, so 2 pi minus 0.566. And I get 5.72. And that's my second answer. So when you take the arc sine arc cosine, arc tangent. That gives you a reference angle. But for you to know that, you have to know the ranges. You have to know the ranges of inverse sine, inverse cosine, inverse tangent. You can't inverse sine and inverse tangents ranges are roughly the same. Or they're the same except for bracket or parentheses. Cosine is a little different. Okay. That's the short version. There's more, but that's the short version. Let's see. Let's see what else we have here. We already kind of did this kind of. Yeah, we kind of just did something like this. Again, if you have any questions, definitely feel free to reach out. Did that. Kind of did this. Let's plug it in. We should really do that. Just did that. Okay, I see some application problems, which, man, a lot of these problems are the same. If y'all have any questions that you want to answer, definitely reach out. All the problems that I'm looking at look kind of the same. Okay, this is a good application problem. I like this. Number 8. Number 9. Maybe I should make it so y'all can see it. Okay. Mountain officials want to build a new ski lift from B to C, shown in the figure below. The distance from A to C is 1,520 feet. They measure angle DAC to be 38 degrees and angle PDC to be 24 degrees. What's the distance from A to B? All right. So, oh, I'll leave off the mountain if that's all right with y'all. So, this is C. This is B. This is A. That's D. From A to C, and they're trying to build. Boom. All right. So, AC is 1,520, and DAC is 38 degrees. And, DBC is 24 degrees. And they want to know AB. Your foot. Okay. All right. So the first thing that we know is that this angle plus this angle is a straight angle, and it equals 180 degrees. So 180 minus 38 is going to equal 142 degrees. After that, we have our other angle here. So 142 plus 24 is 166 degrees. So if I take that from 180, this is 14 degrees. I like to solve for all of the angles first. So now we have a law of sine situation. Okay, because we know that the sine of 24 degrees over 1,520 is equal to the sine of 14 degrees over, we'll just call that AB. So we want AB by itself. Okay. Now, one of the things that I didn't do, normally we do it like this, but you know that we can flip all the fractions. But a little bit of algebra, and we get kind of short steps without belaboring this. Sine 24 degrees over 1520 sine of 14 degrees is equal to 1 over 80. So that means that 520 sine of 14 degrees over sine of 24 degrees is equal to 80. All right. And if we do a little bit of calculations with that 1520 sine of 14, wait a minute. Check your mode. And if you're in degrees, you want to go back to degrees. I cannot tell you how important that is. There it is. Over sine of 4 degrees. And you get, they say round at the end, you get 904 point. Law of sines. We like law of sines because it's easy. All right, we have a one where we are, it looks like we're proving the law of sines. If you know sine and cosine, I'll just do it. I'll just do it. Again, let me know if there are different problems you want me to do. I'm not trying to labor these points. Okay. For a little sketch here. Right, this is H. This is A. This is B. This is C. And this is big A. This is big B. And this is big C. Okay. So, proof. Sine of A, sine of big A is equal to what? All right. When you're using these triangles, you want to make sure that you're using the appropriate triangle. Oh, by the way, that's a right angle. That's important. Okay. So it means that sine of A is split into like three different triangles. Sine of A, this angle A is equal to H over C. All right. Similarly, sine of C, big C is equal to little h over A. Okay. Once you have these particular equations, but multiply both sides by C, I get C. Why capitalize that? C sine of A is equal to H. and I get that A sine of C is also equal to H. Right, because both of these are equal to H, that means that C sine of A is equal to A sine of C. If I divide both sides by C, then I get sine of A is equal to A sine of C over C. And then if I divide both sides by A, then I get sine of A over little a is equal to sine of C over this. The little box means I proved something that I'm done proof. Okay. So that is one of the proofs. This is the proof of this is one of the proofs of the law of sines and cosines. We could have done the same thing with B equal to any one of these and gotten the same thing. All right. So this is that problem. Again, if you have any questions, definitely reach out. Which is 8:52. We'll go for a few more minutes. But if no one has any questions, then we can start. All right. So let's see. This problem is off cosines. Got to do that. Yeah. Okay. So you have a person here. You gotta. All right. Trying to catch my drawing skills. You got a person here who wants to know this is 211 meters. This is 75 degrees. And this is 104 meters. And they are trying to find the length of the. All right. It said carry intermediate computations to at least 4 decimal places and render answers. 10th. My advice for you is when you're doing a problem like this, don't round till the end. Don't round. So if we label these, we'll call this side C. C. We'll call this A and we'll call this B and look. So we're trying to find C. C squared is equal to A squared plus B squared minus 2AB cosine C. Okay. So you can also say that this is that C taking the square root of square root of A squared plus B squared plus 2AB cosine C. And then you substitute in your numbers. Square root of 104 squared plus 211 squared minus 104, 211 cosine of 75 degrees. Now this looks like a lot. This is a calculator problem. You can put in exactly what I put here into your calculator. You can put it in exactly how I wrote it down. Okay? Even though the calculator I have, the one you have will easily do this. I still will do it just to make sure. 2, 4, 11, cosine 75. Boom. Let me see something. 104 plus 104 plus 211 minus 2 times 104 times 211. Ah, if you get a weird answer, check it out. I actually put 21 in the calculator, and I get 209.7. That's my answer. I got something that looked kind of weird. Can I do one like number 15? Let's go back. Sure. This is an application problem. I don't mind. Oh, this is our 12th one. So suppose an airplane is asked to stay in a holding pattern near an airport. The distance of the plane to the airport is described by the following. D of T is equal to 150 plus 78 sine of 2 pi over 13t. Hold on. 101 from the height from the start to 12 or 15. I'll do 15, and then if y'all want, I'll do a number 12 as well. All right. So they want to know in the first 13 minutes after the plane enters the whole holding pattern, when will the plane be 190 miles from the airport? If you think about what this is a sine graph. That's This is a sine graph. It's asking when it's going to be positive or however many miles away from the airport. If it's not at the maximum distance away, which would be whatever 150 plus 228 miles, we know that there are two places that it'll be. Because 13 is the whole, what do you call that? 13 is the whole cycle. Okay. So we got to do a little solving. So we know that 190 is what they want us to get. So let's go to work. 50 plus 78 sine of 2 pi over 13t. Try 150. Yeah, this problem, the numbers get small fast. Is equal to 78 sine of 2 pi over 13t divided by 78. So 40 over 78. I reduce these when I do them just to keep it simple. 20 over 39 is equal to sine of 2 pi over 13t. All right. So we know that there are two angles. We're going to take the arc sine of both sides. That's going to get rid of that. We know that there are going to be two answers for this. Okay. We see the answers are in quadrants 1 and 2. So if I do the arc sine of my answer, which is 20 over 39, I get 9 degrees. I think that I And this is running. Okay, so I take the arc sine. I see them in two places. All right. So the first one, well, so we'll leave this like this. So the first one we're going to do is we have, because I want to round it. So I have arc sine of 20/39 is equal to 2 pi over 13t. I'm going to multiply both sides by 13 over 2 pi. Gets rid of my fraction. That's what I want. So that's equal to t. So the first t, which is our reference angle, so whatever that is, times 13 over 2 pi. Uh, 13 over 2 pi. No, 13 over 2 pi times, nope, delete, times arc sine of 20 over. Okay, I found out what I was doing wrong. You see that 2 pi over 13, that indicates your radians. We see that Mr. Davenport is in degrees. That is where our problem lies. That's why my answer was looking weird. Boom. This is the first one. 1.11. 1.11 is equal to t. But as we said, there are two places. All right. If you look here, this is just the angle. This 1.11 is just right there. You have pi minus 1.11. It's the same amount to see what this is. So if I do pi minus 1.11, I get, no, not 1.11. It's pi minus this right here. So let's do that. So it's 13 pi. This is our angle. So it's 13 pi over 2. So we have to do pi minus this, and that times 13 to the power 13 to the power 2. So go back up. In your calculator, insert. You can go back up to your previous lines and copy your work so that you can simplify some of your grunt work. 5, 4, 3. I went back up and I just put this. The pi minus arc sine of 20 over 39. And then 13 over 2 pi times that. I feel that that's confusing, but this is the answer. And this answer is thus because if you have a positive, sine is equal to something. Sine is equal to positive or negative something. It's not the maximum or the minimum, and it's going to be two answers. Okay. Madison, I don't know if that helped. What about when we do number 12 or does this? Okay, maybe not. Then we'll just keep going. Uh, you need an hour. I'll do a couple more problems, but I don't want this to be. I don't want this. All right, so let's get one like this. This is problem number 13. Let's get a triangle here. All right, you have a triangle. This side is 12. This side is 9. There's not supposed to be a right angle. This is 32. All right, and we want to find the area of this triangle. So if I draw an imaginary height, right, then we know that if that's h, then the sine of 32 degrees is equal to h over 9, right? So our area, so that means that, so 9 sine of 32 degrees is equal to my height. So area of a triangle equals 1/2 times base times, in this case is 1/2, the base is 12, and the height is 9 sine of 32 degrees. And in our case, uh, 0.5 times 12 times 9 sine of 32, make sure I'm in degrees, which I wasn't, and I get 28.62 inches. All right, that's important. I feel like that's important. Uh, there's another one that I saw that was good. Yeah, we did that already. Okay, so find the area of another triangle. This one should be similar. Question number 34. Uh, 14 for us. All right, so this is 55 degrees. This is 12. All right, so call this guy B. So we know that tangent of 55 degrees is 12 over B. So it means that with a little bit of algebra, B is equal to 12 over tangent of 55 degrees. Area is equal to 1/2 times base times height. In our case, it's 1/2 times base is 12 over tangent of 55 degrees. The height is 12, right? And then you put that in the calculator. 0.5 times over tangent 55 degrees is 12, and you get 50.4. The right angle, the right angle makes that really, really easy to determine what the base and the height is. distance plane to the ship at point A. All right. Yeah, this problem is simple, but it has a few steps to it. All right, I'm going to forego the normal drawing. I mean, I'm going to do a drawing, but I'm going to do the simplified version of it. This will be C, this will be A, this will be B, this will be 48 degrees, this will be 55 degrees. All right, so the question is: a pilot is flying over the ocean. You determine that the angles of depression to two ships are 55 degrees and 48 degrees, as shown in the figure below. There you go. The ships are 4 miles apart. Find the distance from the plane to the ship at point A and round it to the nearest tenth of a mile. All right. So, because this line and this line are horizontal, and you have, all, you have a alternate interior angles situation. So that's 55 degrees. This is 48 degrees. All right. So the first we want to find this other angle, 180 minus 55 minus 48. This is 77 degrees. 77 degrees in the middle. And at that point, we go ahead and use our law of sines. We're trying to find little b, right? So we'll say little b over sine of b is equal to that's a little c over sine of c, which we have that. So little b over, can y'all see that? Little b over sine of 58 is equal to little c, which is 4 over sine of 77 degrees. I'm sorry, that's not 58, that's 55. So little b over sine of b. It's 55. Where did I get an 8 from? Guess I need to make, hey, that's the reason to write neatly. Boom. The reason why I do it like this is because simple algebra, we get b 4 sine of 55 degrees over sine of 77 degrees. Put that in your calculator. 4 sine of, nope, clear. Over sine of 77. And you get, they say round to the nearest tenth. So I end up with 3.4 miles. All right. I've droned on and on for 15 problems. At this point, let me know if you have any questions. If not, we will go ahead and shut this down for You are very, very welcome. If you have any questions, feel free to email me. Test is on Friday. Make sure you're ready. Good evening.